morning, my YouTube viewers. In this particular video, what we're going to talk about is simple linear regression. So simple linear regression was part of statistics before it was part of machine learning. But people who studied machine learning may be familiar with simple linear regression because it is one of the basic foundations of machine learning. But statistics was in existence before machine learning was, and that's when simple linear regression came into being. So simple linear regression is a predictive modeling technique that examines the relationship between a dependent variable and one or more independent variables. And so in this particular video, what we're going to be covering is simple linear regression, where you've got one independent variable and one dependent variable. And what we're going to study is hours studied versus test scores. And we're going to do that by writing a Python program. So before we write our Python program, we have to import some libraries. The three libraries that we're going to import are NumPy as NP, which is the numeric library. We're going to import matplotlib.pyplot as PLT, which is the visualization library. And we're going to, from sklearn.linearmodel, we're going to import linear regression. And sklearn is Python's machine learning library. So in addition to that, if you go into stats models, which is Python statistics library, there's also a linear regression model in stats models. But I think sklearn is just so much easier to use that most people opt for sklearn. But some people use some people use stats models as well. So after we have imported our libraries, what we do is we set up our example data. So we have the hours studied is an NP array of numbers 1 to 8, and you reshaped it. And the reason why you reshape it is because it has to be reshaped in order to fit into the sklearn's linear regression model. That's why it is reshaped. And then the hours studied is your independent variable. Now you have your test scores, which is your dependent variable, which is also an NP array of numbers from 50 to 95. So hours studied is your X variable and test scores is your Y variable. So now what we're going to do is we're going to create the model. And so the model equals linear regression. And then you can do it either the way that in this program, or you can say model equals linear regression dot fit brackets hours studied comma test scores. You can do it all on one line if you want. So now we're going to predict on the test scores. So predicted scores equals model dot predict hours studied. So now we predict on the regression coefficients. So we predict on the slope and the intercept. So we'll come down here to the end of the program and see what the prediction was. So the slope was 6.13 and intercept was 41.79. Now we're going to visualize the data on a chart using matplotlib. So plt.figure brackets fig size equals 6,4. We're going to create a scatter plot of the actual data. plt.scatter brackets hours studied, comma, test scores, comma, color equals blue, label equals actual data. We're going to plot the line of predicted values. plt.plot brackets hours studied, comma, predicted scores, comma, color equals red, label equals regression line. And now we add titles, labels, and legend to the graph. So PLT.title is simple linear regression, hours studied versus test scores. X label is hours studied, Y label is test scores. Then you've got your legend and you've got your grid. And so now we're going to show the graph, so this is simple linear regression, hours studied versus test score. So the blue dots are the actual data and the red line is prediction. So you can tell that the actual data is very close to the prediction. And if the dot isn't actually on the red line, then what happens is the distance that the dot is away from the red line is called your error. So that's it. That's your simple linear regression of hours studied versus test scores. And that's going to conclude this video. The next video is going to be on multiple regression, and I hope that you decide to watch it.